Welcome to the Farm Bits Podcast, a product of Nebraska Extension Digital Agriculture. I'm Jackson Stansel.
And I'm Samantha Teton.
And we come to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews and panels with experts, producers, and innovators from all sectors of digital technology, we hope that you step away from each episode with new practical knowledge of digital agriculture technology.
On this second full episode of the Farm Bits Podcast, we are pleased to welcome Dr. John Evans, Assistant Professor of Agricultural and Biological Engineering at Purdue University.
John got both his bachelor's and master's degrees from the University of Kentucky in Biosystems and Agricultural Engineering, and his PhD in Biological Systems Engineering from the University of Nebraska-Lincoln. While at the University of Nebraska, he met his wife, Rachel, who is from southeast Nebraska, and now they live in West Lafayette, Indiana, with their dog, Maggie.
His research interests primarily center around machine logistics optimization, machinery automation, data acquisition, and data management and analytics. All of these research topics pertain directly to harvest operations, particularly future innovations expected in harvest operations.
Farmers understand the logistic challenges that the harvest season presents, and they also understand the importance of measuring crop productivity in the field.
Today, we will talk with Dr. Evans about specifically these topics: harvest logistics and yield mapping, to gain an understanding of contemporary technologies and to glean some insight into opportunities for innovation that may make farmers' lives easier during harvest.
So join us in our interview with Dr. John Evans. So John, what do you think are some of the growers' greatest challenges during the harvest season?
So I think it's that coordination of machinery and labor. So trying to make sure that your very expensive machines are you're not putting more hours on those than you need to, but also the coordination of labor. You know, often it's seasonal labor, and how do you get them there and making sure that they're productive and not sitting around waiting on you to get done with things. And that's a big challenge, and there's so many variables that it's pretty daunting.
Sure. Can you speak to a few of those variables that a farmer might need to consider when they're planning those harvest logistics around harvest time?
So, a few of them are going to be your actual machinery needs. So, you need to match your labor to your machinery, which is often a whole other challenge in itself. But then the timing around that. So, when is that labor going to be there? And is it going to coincide well with when you actually need to have it there? So, often, weather is a big factor in that, especially around like soybeans. So you don't ever know. It's hard to know sometimes when soybeans are going to be ready to cut, depending on the level of dew or humidity. It could be 8 a.m. or it could be 2 p.m. So how do you manage that? And then once you start going, how do you manage some of the outside factors like weight lines at the elevator? That's stuff that you can't predict, but you have to deal with. And if you aren't nimble and have a backup plan, you can end up sitting and waiting for a long time. And you want to try to avoid that as much as possible.
So with these challenges, and you mentioned having like a backup plan, how much time do you think growers should spend on planning their harvest logistics?
So I don't know if there's a specific number, but I think a lot of it starts even before planting. So most people are already doing this, but if they're not, they need to think about it, is trying to time up the maturity of their crops so that everything's not ready to go at once. Because then you start getting into field losses, which we also want to avoid. But then as you go through the season, getting up to pre-harvest, there's a lot of work in terms of, okay, you had a plan in the spring, but that may, depending on how the summer went, that may not be viable anymore. So going through, doing scouting and looking and seeing, when you think each field's actually going to be ready, having a plan for the order of those fields. And it may not actually work out, but you need to have some idea going in. And then I would say a lot of producers, especially owner operators who are in the combine, spend a lot of time thinking about harvest logistics in the cab. I know a lot of the ones I work with, they're constantly thinking about that, in addition to all the other things they have going on with trying to manage the harvester itself. And so, like I said, I don't know if there's a number, but a specific number, but there's a lot of time that should go into it.
Sure. And you kind of already spoke to this in terms of soybeans, and different soybean maturities and how weather and field conditions can affect that harvest logistics planning. I guess, looking more into and maybe considering in the context of the derecho that came through in Iowa this year, for example, how can some of those field conditions that are affected by weather impact how you actually go about planning your harvest logistics and maybe getting some of those still standing crops before you go through some of the more lodged areas, stuff like that?
Yeah, so it can be quite challenging. So like I said, I already mentioned soybeans, when the variability and when they're actually going to be ready to run, and even when they're when you have to stop. But another good example of that, like you mentioned, is if you have down corn, planning for that, that's going to take a lot longer to get through. Usually requires some more equipment. So that's a whole nother challenge. In addition to soil versus crop conditions. So your crop may be ready to run, but in areas like if you have a bottom field that has poorly drained soils, you probably shouldn't be on that. You're going to do more damage in the long run. So being able to work around that. So maybe you that field was in the plan, but maybe you skip that one to go on and do a field that's actually ready from a soil and crop condition perspective. There's just a lot to think about.
So can you speak to why this is so important? Like, what are the potential savings associated with having a really efficient harvest plan versus maybe one that's not so efficient?
So the two obvious ones are going to be your labor cost and your machinery cost. So you obviously don't want to pay for more labor than you need because you have bottlenecks in your system and people are just sitting around doing nothing. And at the same time, you don't want to put more hours on your machinery. But probably the biggest one is going to be your field losses. So if you are not getting in and out in an appropriate amount of time, you get pushed back into late December or late November, early December, then your chances of a weather event coming through that are going to increase your field losses really starts to get more and more. We always worry about with corn, especially when it gets brittle, and we worry about snow with soybeans taking them down. So we need to be as efficient as possible in getting in and out of the fields.
What do you think is the best thing a grower can do today to help them improve their harvest operation?
I think that there's the simple approach, which is being analytical about identifying bottlenecks. So that's something that doesn't really take any money. It's just a little bit of time in terms of figuring out what's really taking the longest. Is that you're constantly waiting on trucks because you don't have enough, or because your elevator is slow and they spend hours in line there. So really trying to identify those pinch points and looking at ways to alleviate those. And so that's something farmers can start out with, and a lot of them are doing that already. But then take an extra step to say, like, okay, let's start taking a log and figuring out how much time I actually spent waiting on the truck to get back. And then you can really start putting numbers to those, that evidence you've seen in terms of how much time it's costing you in the field. And then you can start looking at, okay, well, I can afford to get another truck if it saves me X amount of time. So that's kind of the base approach. Then you can start, as you get more into that, you can start weaving in some of these new offerings from different companies. But I think in the next few years, we're going to see a lot more coming out from the bigger companies.
So are there any good software tools out there that can help farmers make decisions about, how to be more efficient? Can they evaluate some of those savings, or is that's something that we're kind of still waiting on out there technology-wise?
So we're starting to see some of that. We got companies like Cropzilla who are working on trying to help farmers make harvest plans or just whole farm plans, really. And then And that's really more on the order of fields you're going to go after. And in terms of actual in-field logistics, you're starting to see more companies look at that. A lot of big 3 companies are looking into that. They haven't really rolled out anything to date. There are some smaller companies like Solinec who look at in-field logistics. And I would say one thing that has yet to really be harnessed, at least widespread, is the power of IoT and connected machines. So, and that's kind of a color barrier because most manufacturers, they're pretty good at handling their own machines, but most people don't have a fleet of purely green machines, especially when you talk about the whole system. So John Deere doesn't make a semi truck. And so they're not really good at handling that aspect, which is a big one. And so I think that's going to be big going forward, is this connected machinery and starting to build some intelligence around that to help the farmer. And so he's not sitting there spending a lot of his time thinking through these harvest logistics while he's in the cab, and getting some help there is going to be big in the future.
So kind of synthesizing, a few of your answers to the last few questions, you've talked a little bit about how there's an opportunity for IoT and connected machines and trying to communicate across machines. I know Sam and I have talked to growers who have said that, their biggest issue is trying to figure out whether they should send the truck to town with the grain or whether they should send it directly to the grain bin. And obviously data communications across machines is a huge issue in trying to make this all work. And so growers are kind of in a situation right now where they're piecemealing it between several different apps, where they have just a regular tracking app that they're trying to use to see, where the truck is in relation to the field they're harvesting at. Is there an opportunity here for a third-party company to step in and operate off of the CAN bus systems on these different machines and try to coordinate them and try to get this into an integrated application? Or what are your thoughts there?
Yeah, I think so, and I've seen it I've seen it happen one time with Farmable. I've seen a fully integrated system that they've been able to put together. I think the biggest issue right now with them is, at least from the grower's perspective, is the cost of the equipment, and then at least right now, is all they're getting back is essentially positional data in terms of their, they might get some information from the grain cart, but to really make this system more powerful, we need a kind of a brain around it, so that, essentially this is another set of data that the producer right now has to ingest and turn into information. Well, if we can take some of that burden off of him and say, integrate some stuff from Google or, any kind of mapping software to say like, okay, my truck's here, and tell the operator that based on today's operations, we think that your truck's going to be back here in 30 minutes, or he's already on his way back, and we know that it should take him 10 minutes to get back, and really start to turn more of that data into information for the farmer. I think there's a big opportunity there. You look at Google right now, when you pull up a business, you can see when they're usually busy. Getting that kind of technology to the grain bin or to the elevator level would be neat and helpful. I don't know how or if we'll be able to get there, but that's one thing that continually, that is such a big piece of the pie that producers don't have any control over. And the more we can do to help solve that and at least give them insight into what's going on there, the better off we're going to be. And I don't know how you do it, because most elevators are not going to be probably very forthcoming with that, because they don't want to drive business away from them. Mm. And then on the way Google does it with businesses is just huge numbers, and you're not going to have that with elevators or most elevators. So I guess I don't know, but I think that is one thing that's worth really looking into is how we get past that hurdle. And it's like you say, it's so big for planning. And then also in terms of, I think that also justifies a lot more on-farm storage. So, if if you've got enough on-farm storage, then you can just start using that as a buffer. So maybe you don't even take anything to an elevator until you have a rainy day and you're pulling it out of your own bins. I've seen people do that where that way they know what their system's going to look like.
That's really interesting. It's also interesting, like different regions of the U.S. have different amounts of on-farm storage. Like I think Nebraska has a lot more on-farm storage.
Yeah, I mean, especially around, and it's also interesting regionally how the density of elevators. So, where my wife's from, there's in southeast Nebraska, there's quite a few small elevators that they can choose, kind of pick and choose. But, I kind of thought it would be similar here when I moved to West Lafayette and talking to the Purdue farm managers, there's really not many options. And they're actually consolidating even more because of like OSHA regulations. Like the companies like ADM don't want to spend a lot of money on small elevators. So they consolidate more. And now guys are having to truck 40, 45 minutes and don't know what the line's going to be. And so it gets really prohibitive and really incentivizes a lot of on-farm storage.
That is interesting. So switching gears a little bit, where do you think harvest operations are heading with increased automation? Will we get to the point of driverless grain carts or combines?
So I think with companies like Smart Ag, you already have some demos of driverless grain carts. A lot of the big ag companies are working on this. I think we'll get there. I think grain carts will be the first domino to fall. Combines are going to be a lot trickier. We're already heading in that way in terms of subsystem automation. So if you look at most of the big machinery companies offer some kind of process automation. So they're looking at grain quality and then doing the adjustments to the combine automatically now. And so that's a big step. I think the actual autonomous navigation is not too far off. I think there's a lot of work to be done, however, in terms of machine vision. We're in a very complicated environment. We're trying to look through corn, look through beans to identify things that aren't supposed to be there. And so I think there's a lot of work on that. And then on the kind of legal side of it is, right now these are all very big machines and they're only getting bigger. And so at what point do you trust them to not get loose? Because if they do, they're going to cause a lot of damage. Mm-hmm. But I think we'll get there.
So you talked about you just talked about how machines are getting bigger, and I guess we've also seen some of this trend within the automated machinery space to move towards smaller tractors. Do you think that smaller autonomous vehicles or kind of swarm technology will ever have a place specifically in harvest operations?
That's a good question. I think it's good. Harvest operations are going to probably be one of the tougher spaces to go smaller, just because of the cost of technology and processing. There really is a economy of scale there that's working in the machine's favor to get bigger. In other operations, it'll certainly happen faster, but I think there's an opportunity. It's just going to be as the cost of technology gets less and less, and I don't know how long that's going to take, but when you think about all the sensors you're going to need to govern one of these big machines, that's just going to multiply when you get into swarms. So, if you want to have good GPS accuracy, you have to have RTK, and that's obviously not cheap. And then all these other machinery vision components really get pretty cost prohibitive to go small right now, at least.
Considering that same theme of being, smaller, I've seen that some of the companies are kind of moving towards trying to get row by row type resolution. So last year we had some data come in from one of the new John Deere combines that was coming in at like 5 hertz, and they were reporting at, sub full swath width resolution with their yield. And so kind of getting into this idea of yield mapping and yield data resolution, how much resolution do you really think we can get to for yield data without much error? And what would be the technology pathways that we may take in order to get there?
So I think we could probably get, I think it's crop dependent. I think corn's going to be easier. And I know there are companies that are looking at using essentially vision systems to try to get a distribution of the grain coming in, and then just saying, okay, we know from the yield monitor how much volume we have, and then from the vision system we know the distribution of volume. I don't know right now how accurate that's going to end up being, but for that we could definitely get down to the per row basis. Soybeans get a lot harder. It's really hard to tell that from a vision system, especially at the volume of plant coming in. So I think we'll potentially get there. And soybeans are also hard too, because there may be, often the platforms are much wider, and so you really do need to get better resolution, but it is, like I said, a much harder problem than corn. So in terms of value, I think there is a lot of value, especially when we're using yield data maps to make prescriptions for fertilizer and other inputs. And so, right now, in terms of like planting or applying fertilizer, we can get really spatially dense. I mean, easily down to the row, and along the row as well. So I think it'll help. I think there's still a lot of research to be done in terms of, we're also adding in a lot of other data layers like soil fertility that are still very sparse and are cost prohibitive to go much denser. And so that may end up being the limiting factor anyway. It's just, I think there is a lot more research to be done around that area though.
So to leave you with this, what is the biggest piece of advice or message you want to leave the listeners with?
I think it's just to continue to try to get better every year. You don't have to go out and buy the latest and greatest right now. Even incremental change is going to help your operation. And like I said, farming's pretty unique in that, especially in row crop grain, all of your income comes at the end of the year, and how you handle that harvest can have a big impact on that. And so, if you can continue to get better, whether it's through just, manually tracking where your bottlenecks are and trying to resolve those, or it's incorporating some of this new technology, it's all going to help you in the end. So just continue to work and get better at your harvest efficiencies.
Thank you, Dr. Evans, for joining us today. John was actually a former member of our research lab, so it was great to catch up with him and see how he's doing and the things he's working on now. So I thought he did a great job of covering things that growers can do or use today, but also where we're going in the future. So my favorite part was when he talks about how most people do think about like their bottlenecks or things slowing them down, but maybe don't actually write down a time that they're spending on that to then justify some big purchase decisions.
Exactly. And what was really interesting to me, when John talked about the logistics issues of the trucks communicating with actually the field machinery and trying to understand wait times at the grain elevator and trying to make decisions about, do I take it to on-farm storage? Do I take it to the grain elevator in town? And where we could potentially go with that, maybe using technology like Google Waze that they already have out there. That's really cool stuff. And I'm excited to see what research goes on in that area in the coming years. And so that's all for today's episode. Mm-hmm. I really hope that you'll join us next week as we talk to Dr. Joe Luck about yield data quality and also yield monitor calibration and yield monitor function.
Thank you for taking the time to join us today on the Farm Bits podcast.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
If you enjoyed this episode and it sounds like something you'd listen to each week, subscribe to the podcast and set your notifications to let you know each time we release a podcast.
We would love to hear from you with your feedback. So if you have comments or questions for us, please reach out to us over email at nedigitalag@unl.edu, on Twitter at nedigitalag, or in the reviews section of your favorite podcast platform.
See you next week on another episode of Farm Bits.